Ladies and gentlemen, hello. This video is all about compound inequalities that have the word or in them. So here are some basics for compound inequalities with the word or. It's going to have at least two parts, just like the word compound implies. It's going to be written as two or more separate inequalities that has the word or joining them. It is true if one or more of the inequalities is true. Just like in life, what you say with the word or is true if one of them is going to happen. So you could say, I am either going to the football game tonight or to the movies, and you are telling the truth if one of those is true. So in the math problems, the solution is any number that is a solution for any inequality in the problem. Just like for you, you could either go to the movies or to the football game. You would be telling the truth. It just has to fit one of the inequalities, and that's how it is with the numbers also. The arrows are often going to point in the opposite directions, but they don't necessarily have to. But typically you might have x is greater than 7, and x is less than or equal to 2, and that's what it would look like. Occasionally, we're going to try to trick you, and we're going to have, I don't know, something like this. X less than or equal to 7, x greater than or equal to negative 7, and since it's or, only one of them has to be true, which means it has to fit this inequality, or it has to fit this inequality. In either case, that would be infinitely many solutions. That's not going to happen very often, but it might happen occasionally, that it's going to fit either solution and be any number in the whole world. So here we go. Let's look at some more here. And an important rule for compound inequalities with the word or is that the word or must be in your answer. You cannot shorten it into one of those sandwich inequalities. For instance, 2 is less than x, or x is less than 0. If you wanted to make that a sandwich inequality, or just a mathematical sentence, you would say 2 is less than x, and x is less than 0. You could also flip that because typically your numbers go in numerical order. So you would flip that and you would get 0 is greater than x is greater than 2. But if you take out this x in the middle, you are left with 2 is less than 0 and 0 is greater than 2. That is not true. So by combining them into one mathematical sentence, you have created something that is not true. So when you're doing these problems, remember to use proper mathematical notation and don't make a sandwich for or inequalities. Instead, write out the two inequalities and write that word or. Here's an example. X plus 6 is less than negative 4, or 3x is greater than or equal to 14. I'm going to go ahead and put a squiggle between here, and I'm going to solve it. I'm going to subtract 6 from both sides, and I have that x is less than negative 10. If I go to graph that, I know it's covered up, but I know that this last number here is negative 10, and x is less than that. If I come over here, I know to get x by itself, I've got to divide by 3. So I'm left with x is greater than or equal to 14 over 3. I know 3 times 4 gives me 12 with 2 left over to get me 14. So I know x is greater than or equal to 4 2/3. I don't have to be exact, but I'm going to put a line there. Greater than or equal to tells me it's over there. So any number that is over here or any number that's over here is a solution to my compound inequality because it only has to fit one of the solutions, only has to fit one of the inequalities. Here's another example. 5x is greater than or equal to 15, or negative 3x is greater than or equal to 21. I'm going to go ahead and divide by 5. And I'm going to get x is greater than or equal to 3, which is here. Going to give it a solid circle, and if it's greater than, it's in that direction. Here, I've got to divide by negative 3. So I'm left with x and negative 7. Remember, when you divide by a negative, you flip the sign. So I have x is less than or equal to negative 7, which is here. So 9 would be a solution because it fits this inequality over here. Over here, negative 8, negative 9, negative 10.123. Those are all solutions to this inequality because it fits one of them. There is no number that makes both of them true because there is no overlap. So any number that makes one of them true is a solution to the inequality. So here is your try it on your own problem. Go ahead and work that out. Good luck.